going to be looking at combining those components. So how do I combine the x and the y components back together? So thinking about our plan, we want to resolve the vector into components, or the multiple vectors into components, do all of my algebra, do all of my motion equations, and then I need to combine them back together at the end. So let's talk about how we're going to combine them. So now that I have my final components and I want to bring it back into a final vector, I'm going to need to find the magnitude by using the Pythagorean theorem, and in order to find the angle, I'm going to have to implement the tangent function. So the tangent of theta is going to be the opposite over the adjacent, and so in order to solve for this theta, I have to do the inverse tangent here. To get that inverse tangent on your calculator, you do have to hit second and then the tangent button. Okay, so let's do a couple of examples here. So I'm going to do two, and then I'm going to have you do two practice ones. So right down at the bottom of the page, there's an example. So in each of these cases of the following, the components of the vector A are given. Use trigonometry to find the magnitude of that vector and the counterclockwise angle it makes with the positive x-axis. Also sketch each vector approximately to scale to see if your calculations seem reasonable. All right, so I'm going to do A and C, and then I'm going to have you try B and D. So A has 4 meters and 5 meters, and they're both positive. So how I draw these is I draw one, and then I draw the other one right off the end of the first one. Because the idea is that this is my starting point, this is my ending point. Whether I take the component method to get there, or whether I take the magnitude and direction method, I end in the same spot. So whenever you draw your components, you got to draw one and then the other. Okay, so here we go. So it says it's moving what, 4 meters in the positive x direction, and then it moves 5 meters in the positive y direction. So I drew one vector, then I drew the next one. I now need to find the resultant vector, it's called, which is to find the magnitude and the direction. So in order to find this magnitude over here, I'm going to take the square root of the two legs squared and added together. So I have 4 squared plus 5 squared. And to find this angle here, theta, I'm going to have to take the inverse tangent of the opposite side, 5 divided by the adjacent side, 4. All right, so let's type that in our calculator, see what we get. We end up with 6.4 for the magnitude. So I have 6.4 meters at, and we get an angle of 51.3 degrees. And you're not done. Whenever we draw these, what you have to make sure you do is you have to give it a reference. And so for instance, it always has to be the angle between our vector and one of the axes. And so ours is relative to this axis, which is my positive x-axis. Positive y, negative x, negative y. So is this counterclockwise from that positive x-axis? Yes. And that's what they asked for. They wanted counterclockwise from the positive x-axis. All right. Let's try the next one. Let's try C, see how that works. We might not get as lucky on the angle on this one. So C tells me that I have 9 meters per second in the positive x direction and negative 17 meters per second in the y direction. All right, so let's draw those. So I have 9 meters per second in the positive x, and when I draw those components, I draw one, and then I draw the other one right off it, and then 17, that's maybe 17 meters per second in the negative y direction. Now I need to find that magnitude and direction, and so this will be my angle that's inside my triangle, and this magnitude is going to be 9 squared plus 17 squared, and then take the square root. So my magnitude, when I type this into my calculator, square root of 9 squared plus 17 squared, comes out to be 19.2 meters per second. Now I need an angle. All right, so my angle here I can find by the inverse tangent function. So the inverse tangent of opposite is 17 divided by the adjacent, which is 9. So 17 divided by 9 gives me an angle of, what do we get here? 62.1 degrees. Now, if I look at this, it makes an angle with the positive x-axis, but the problem is it's clockwise of the positive x-axis. And they ask specifically in the question, what is the angle counterclockwise from the positive x-axis? So they actually want me to find the angle that starts here at the positive x-axis and goes counterclockwise to this point. So how am I going to figure that out? Well, if I know all the way around is 360, if I back off 62.1 degrees, I'll get it. And so we end up with 297.9. So I get 297.9 degrees, and again, this is counterclockwise of the positive x-axis. Okay. So there is my answer. So now I'd like you to go ahead, try B and D. I'm going to quick flip those up on here so you can see what they look like in the answers. So hit pause, do those two, and then come back. All right, so let's take a look at B and D that you did on your own here. So you drew your picture. It should look something like this. You should have got 6.7 kilometers for the magnitude. To get the angle, you got to start over here at the positive x and rotate counterclockwise 180 degrees plus that theta value you figured out for a total of 243 degrees counterclockwise of the positive x-axis. For D, same kind of deal. You draw your two components, one then the other, and then you find your angle and your magnitude. For a magnitude, you should get it 14.4 newtons. For the angle, you're going to have to do 180 minus that theta value you found to find the supplementary angle there of 123.7 degrees counterclockwise of the positive x-axis. There you go.